Hi everyone, today I'm going to share with you a project I'm going to work on to build a small portable GPS module which will be controlled by an Arduino Mini. The module itself will be capable of providing the correct date and time and the longitude and the latitude. So let's have a look at the block diagram and pinout for this module I propose today. Here we have a block diagram with the pinout connections which I plan to build today. I'm going to use a small GPS module which will be connected to a Arduino Pro Mini. The Arduino will then be driving a display module, and I plan to use a small OLED display which has a dot matrix of 128 by 64. All of these modules will be supplied with a 5V DC supply, and to obtain that I'll be using a 3.7V lithium polymer battery. That will be switched in via a little push on off switch there into a DC to DC converter to give me my 5V out. I'll also add a Lipo battery charger module here to charge the lithium polymer battery, and that is accessible through a mini USB socket. So let's have a look at the components I plan to use today. There you can see the GPS module with its active antenna. There is the Arduino Pro Mini module. The one I'm using today is going to be using the Atmega 328 chip, and it's a 5V version, this with a 16 MHz crystal. The display there is a OLED display with a resolution of 128 by 64, and this particular one is controlled by I2C bus on the pin connections there. In addition to these three modules here, we have a small DC to DC up converter module, and that's going to be used to convert the 3.7V DC from the lithium polymer battery up to the 5V that we require for these three modules here. And then the module next to the battery there is simply a lithium polymer little charger module which we'll be using so we can recharge that battery. Now, in addition to these active parts we'll be using on the project today, we'll also need something to be able to program the Arduino, and therefore you will need something like this. This is a USB to TTL converter, and this enables us to program the Arduino from our computer. Just worth having a look here, there's two different types of GPS modules that you'll find on eBay, and this one comes with a larger antenna. There's a small antenna there, but the important thing to bear in mind is that when you look at the connections on this one and the connections on this one, you'll find that the ground and the VCC on this one, there's the ground, there's the VCC. On this one it's the opposite way around. There's the VCC and there's the ground. The RX and the TX pins are the same way on both modules, but the power supply input is reversed. So you need to be very careful whichever module you use that you wire it up correctly to the plus 5V. Here you can see I've laid out all the modules on this breadboard so we can test the circuit. The Arduino Mini is here, and you can see that is connected to the OLED display via this green and grey wire. The green and grey wires, if I just explain those, the grey wire first of all is going from A4 of the Arduino, and that goes to the data pin on the OLED, which is the SDA pin. And then the green wire is going from A5 on the Arduino to the clock pin on the OLED display, which is labelled SCL pin. So that is coupling the Arduino to the OLED display through the I2C bus. Now the GPS module here, that is going to the Arduino onto its port pins, and the ones we're using is pins 3 and 4. And pin 3, you'll see the orange wire there, that is going to the TX pin, the transmit pin, on the GPS module. And then pin 4, which is the yellow wire, that is going to the RX pin on the GPS module, which is the receive pin. Now all the other wires you see here, the red and the black, that's just supplying the 5 volts HT supply to the Arduino, to the OLED display and to the GPS module, and they're all going to this point here, which is the output from the DC to DC up converter. I haven't got the battery connected yet, but on the input of that we have the USB Lipo charger unit there as well. And then the pins coming out from the Arduino, you see I have a lead there coming off which is plugged in, and that is going to our USB to TTL converter module, which we'll use for programming. What I'll do now is I'll connect the battery and we'll just test the unit. Okay, we'll just connect this lithium battery. I've installed some software into the Arduino so we can see at least the display working. Okay, there you can see the unit seems to be working okay. We have the display I have here at the moment is one of these OLEDs where the top section is yellow and the remainder is blue. You can get these in variants. Some displays come all blue. You can get some others that are white. This is the little project box I plan to use today. It's fairly small really, but it should be suitable for this project. It's 85 millimeters across. It's 55 in height, and the depth of it is 30 millimeters. It's quite nice, this little box, because it's got a little hole already pre-drilled there for my on-off switch, which I propose to use a push on-off switch. And this area here, which is recessed slightly, I propose to cut out for the OLED display, cut out a section just there, so the OLED display then fits behind that and then fixes to there with maybe a couple of screws. This particular project box is quite nice. It comes with a little matrix board inside. You have some solder points on one side and the other side is just plain. I plan on using maybe a couple of little terminal pins there to use as my connection points. You have the fixing screws and some rubber feet as well. So quite a nice little unit. I'll need to cut out at the side there so I can fit the access to my USB Lipo charger module, and we'll probably need to cut out a little bit at the front where we can connect to the programming pins for the Arduino. Okay, so there's the project box we're going to use today. Right, I've just positioned and soldered the USB Lipo charger module there onto the board, and just with two pins going through the board there, and it comes through to the other side. Now the interesting thing is that the positive side of the Lipo charger module is there, so when I turn it round, that's the positive side, and that will line up quite nicely with the DC to DC converter. So that should slot onto those, because the positive side of that is there and the negative is there. So what I need to do is just bend those pins in slightly, and then I think I can solder the DC to DC converter there on top of it, back to back. Let me just do that and come back. Right, there you can see I've got the DC to DC converter module there, nicely soldered onto the pins that came through from the Lipo charger module there. The only thing I've noticed, obviously we've got a gap there, so it might be nice just to put a little bit of padded tape there. I have some of this double-sided padded tape here, which I think I'm just going to stick behind the module there. So let me do that. Now there you can now see I've just put that little bit of a padding behind the module there. Right, let's just see how we can position the other modules in the board. It's a bit tight fit, but let's see. Here we have the GPS module, and my intention is to fold the antenna over like that, so that sits on that side of the board, and then I'll put some sort of double-sided padded tape there, so this will sit down onto that. So that would be positioned hopefully around there, and that leaves this space here for the Arduino. What I've decided to do, I had some bent pins like that, which I've then put in there, and then I had some straight ones, the straight pins, so 6 of them, and I've put there next to it, so they both go through the board. If I turn the board round, so then what I've done is bent those wires across, and I'll solder them onto the pins there, and that will simply mean then that the Arduino Mini will simply sit on top there, and then I can simply solder that. So let me first of all solder those pins. Right, now I have the pins soldered in place. They're soldered on the back, connecting across, and what I've also decided to do is put a little bit of double-sided padded tape there, so when I put the Arduino on, it's held in firmly. So let me just take that off, put the Arduino on, so that now sits quite nicely on that padded tape. So let me just solder those connections on there and we'll come back. The Arduino micro is now soldered in place, so we need to position the GPS module. I already have some pins soldered on here with VCC, RX, TX and ground, and my intention is to fold the antenna over like that and then sit that module in there. But obviously, because I've got these little printed circuit rings around here, I'm going to put some double-sided padded tape on there to sit the module on. So if I position some tape there, and the idea then is that will then sit on top of there, and then when we put the cover on, it should fit. Yeah, it fits quite nicely. Okay, I decided to take those pins out, and I've soldered some coloured wires onto the 4 terminals on the GPS module. So I have the red wire is the VCC, the yellow wire is the RX, the orange is the TX, and the black one is the ground. So let me position the module onto there now. There we have the GPS module now. That's pushed and stuck onto the double-sided pad at the back, I'm going to put another piece of this double-sided tape, padding tape, there. Take that off, and then the idea is that the antenna would then simply just stick on top of that. Well, I've soldered an earth wire onto the output from this module here, which will be the common earth. I'll put it onto a pin shortly. But I just want first of all to position the on-off switch. I have one of these small on-off self-latching push buttons, just single pole, but I need to position it so when I'm looking through the top cover I can have a button coming through that round hole there. So let me see if I can just position that somewhere in the corner of the board, and then tuck these wires away. And then position the top on. Okay, and I think there you can just see the top of the white of the push button there, so it looks as though it's lined up. So I think that position is correct for the button, so I'll position the button in there. So there's the on-off push button positioned. The other thing I also decided to do is, on the lithium polymer battery I've got a little 2-pin plug, and I decided to put a socket on the underside of this board. You could wire it straight in if you didn't have the plug and socket connection, but just to keep it neat, the idea is that the battery will sit there in the bottom of the case, and then what I've done now, I've just soldered, I've got a little 2-pin socket there where the battery will just plug straight into that on the other side of the board. So the connections then on the front side there, we can solder to those connections at the top. Right, I've soldered the 5 volts lines in there. You can see I've put a few pins here next to the on-off push button switch, and then I've used that as my common earth, and then that is my HT plus 5 volts, and then I've got a couple of pins here next to the on switch where the switch contacts go to, and then feeding the DC to DC converter, and then the output of the DC to DC converter, the wires are going around here, and then they're going to these 2 pins here, so that's our plus 5 volts. So that's now all wired up, so I'll just give that a test. I'll plug a battery in and see if the so that now just plugs on the back, and then if I now switch on, there you go. So that's obviously powering up, and the Arduino at the moment is just flashing the LEDs. It's not programmed yet, that one. Okay, so then the next thing we'll do is we'll wire up the display, and then we'll give it a test. I've just wired in the OLED display to the board, so what we'll do now is we'll switch on and give it a test. Seems to be working, the display's come on okay. Now, one problem I've just realised is that on the back of the board I put a socket for the battery connector there, but unfortunately when I plug the battery into that, it's just sticks too far out for it to sit neatly on the bottom of the casing, so I'm going to have to reposition this socket so it goes sideways. So let me do that first, and then we can put the board in the casing. I've now fixed the display into the case. You see it's there, it's fixed into the case, and I've also put a push button onto the on-off switch there. The button that went on originally was a little bit too short, so I had to stick another one with super glue on top of it. So that's made up of 2 buttons, and that then comes through the case. I've screwed the board now down, the battery's underneath, so we can now hopefully close the case and give it a test. And you can see I have the module now plugged into the computer using the USB to TTL interface unit there, and we program in the Arduino Pro Mini in the module. Let's just have a quick look at the software I put together for this project today. If we look at the start of the program here, we're including a number of libraries. I'm including the SPI library, the Y library, and I'm also using some Adafruit libraries. You'll see here the Adafruit, the GFX, which is a graphics display library, and I'm using the Adafruit library for the OLED display, which is the Adafruit SSD 1306. I'm also including the software serial library because I need to set up a software communications channel for the GPS module, and another library I'm using is the tiny GPS library, which will give me some of the commands I want to use for the GPS module. So the things you need to probably download from the internet, these 3 libraries here, there's the tiny GPS library and the 2 Adafruit libraries you'll need to download from the internet, and then install them in the libraries on your Arduino software interface. The next command there, you have 2 commands there to do with the OLED display, and that's just initializing the OLED display there, those 2. We then set in the object for the GPS, the tiny GPS, and we're giving that the name, in this case just GPS. We're then setting the software serial pins on the Arduino. I'm using pins 3 and 4 for this communication to the GPS module. Pin 3 I'll be using for the transmission, and pin 4 for the receiver. So you'll see there in the comments. The next section is the setup procedure, and all we're going to do here is set a few variables. We're setting the baud rate there for the software serial communications interface at 9600. We're then setting some variables here, and this command here is initializing the OLED display. We need to identify the address for the OLED display for the I2C bus, and in my particular case that was 3 hex in hexadecimal, the address. You may find on some OLEDs it may be 3D, but all the ones I've used so far have all been 3C. And the next command there is simply to clear the display. Right, having cleared the display, we're then setting the text size to 2, which is large text, and we're setting the text format to be, well, it says white there, which is sort of white on black, but we'll be printing either yellow or blue on black, but that's the command you need to use. We then set in the cursor position to 0, 0, that's column and row, and we're printing across the top of the OLED display then Scullcom, but you can change that to whatever name you wish to put in there. We're then altering the text size to 1, which is for the smaller text. We're then moving the cursor position to row 18, but we're staying in column 1, and we're printing the word GPS system. We're then moving to row 30 with the cursor, and we're setting the colour of the text, it says there black, white. That's going to print you a white or a blue, whatever the colour is, block across the screen, and then you'll have black text inserted in that. So it's like a negative text, and we'll print in there the word initializing. We then move the cursor to row 40. We revert the text colour on the screen to the normal colour again, and we type in the words trying to locate the satellites. And the next command you see there is simply moving the cursor position to row 57, but staying in column 0. We're then just simply printing the words "please wait," because we'll be waiting now for the unit to detect a satellite. It can take several minutes for this to happen, so you're just looking at the sort of the introductory display on the OLED, and we just simply now have to wait. The next command, display.display, that's just to refresh the OLED display, and then I put a short delay in there of a second before I clear the display. Right, the next part of the program is the main program loop. Here we have the main program loop here, this section from there to there, and that's quite simple. All that's doing is checking to see if we have new data coming from the GPS module. If so, it then goes and asks to carry out this subroutine here, which is called GPS dump. And what GPS dump subroutine is going to do is extract the data from the GPS module and convert it in the format which we can then display on the OLED display. So that's the main program loop there. So let's have a look at the next part of the program, which is the subroutine, which I've called the GPS dump. Here we have the GPS dump subroutine, which is to print the data to the OLED display, and we're just at the beginning here. The first thing we do in there is actually go into another subroutine, which will print the date and the time. Then we're setting a few variables there for the latitude, longitude and the altitude, and we're clearing the display. We're then setting the text size to 1, which is a small text, and the text type to normal, which is white on black screen. In our case it'll be blue text. And the display cursor is then positioned at the top left hand corner, 0, 0, row 0, column 0. And then we have another command there to do with the printing the date, the time there. This next section then, we're extracting the latitude and longitude data. We're setting the cursor position now for row 20, but staying in column 0. We're printing the word altitude. We're then getting the altitude data from the GPS module with this tiny GPS command here, and printing the digits on the OLED display. We're then moving to column 100 and staying in row 20 to print the letter M to signify meters. We then change the cursor position to row 30 and print the words SATs for satellites, number of satellites, and the next command is just going to print us the digits of the number of satellites we're receiving. We then move the cursor to row 40 and we print the word latitude. Next to the word latitude, we actually collect the data and print the digits giving us the latitude information, and we then set the cursor on the display to row 50, print the word longitude, and we collect the longitude data and print that also next to the word longitude. You'll notice there I've got a comma 6 and a comma 6 there. That's to 6 decimal places. And the final command there is display.display. That's update the OLED display. So that ends that part of the subroutine. The next subroutine I've got on here is to do with testing the GPS module to see if we've got new data. So this is the testing for new data subroutine here, and simply we're using the command encode to extract the data from the GPS signal byte by byte, and it returns true if we have some new data or false if we don't. And the final routine I have on here is the get the date and time routine for the display. Here you see the date and time routine, and we're setting some of the variables here. This command here, which is the gps.crack_date_time, extracts the year, the month, the day, the hours, the minutes and the seconds, and the rest of the program there is simply formatting it in the order we want to display it on the OLED display, and then returning back to the main program loop. There's a couple of items in this part of this subroutine which you could remove if you wish, but I've just left them in. I was using them when I was testing. I've got hundredths there when I was looking for hundredths of a second, but I'm not actually printing hundredths of a second, so although I'm collecting the I'm setting the variable byte for that, I'm not actually using it, so you could remove that if you wish. And I've got age there. I'm assigning a constant there for age is the age of the satellite signal we're receiving. Again, I was using that on testing, but that could probably be removed, but it's just left in there. It doesn't make any difference. So there you have the software for this little project. I'm sure you can probably improve this, or even add other things, other data to it, and extract other data from the GPS module and display that also on the OLED display. Here we have now the finished unit, all cased up with the on-off button coming through the front of the case. So if I just switch on and we see if it's working. Display coming on. That's just the intro display, waiting now for it to detect satellites. This normally takes a few minutes. You find if you take the unit outside, it usually locks on quicker. Well, there we are, we're indoors at the moment. It's locked onto satellite. We can actually see there the number of satellites it's locked onto is 5. So there we are, we're getting the altitude, we're getting the latitude and the longitude, and the exact date and time. As far as programming the unit is concerned, we now have a slot there at the side where you can plug in your USB to TTL adapter to program the Arduino. I plan to have a little plastic cover that blocks that when we're not programming the unit. Well, I hope you found that little project of interest, and I'll see you all again next time. Bye for now.